set of rings. These rings give flexibility to the chain. Look at the ends of the chain. They contain brass handles with swivel joints. This mechanism prevents the chain from being twisted. The chain contains markers called tallies. Tallies are pieces of brass shaped somewhat like a leaf and hung at regular intervals on the chain. By counting the tallies, a distance equal to a part of the chain can be measured. Now, let us look at arrows. Arrows are short rods measuring about 40 centimeters in length and 4 millimeters in thickness. One end of the arrow is pointed and the other end is shaped into a loop. Arrows are used to mark the point on the ground where the length of a chain ends. Now, let us see what pegs are. Pegs are bar-shaped pieces of wood. One end of the peg is tapered so that it can be driven into the ground. The pegs measure about 18 centimeters and are driven into the ground to mark the positions of service stations. Now let's look at ranging rods. Ranging rods are long poles measuring about 2 or 3 meters. A pointed bit of iron makes up the bottom end of the rods. The ranging rods are driven into the ground to mark some intermediate points in the survey line. As the rods are thin, they are nearly invisible from a distance of about 200 meters, so a red, white or yellow flag should be tied to its top. Finally, we have the plumb bob. The plumb bob consists of a string tied to a weight made of iron or brass. When the weight is suspended from the string, the plumb bob hangs in a vertical position. The plumb bob is helpful to mark points on the ground when using the chain on sloping ground. To summarize, the instruments used for chaining are chain, arrows, pegs, ranging rods and plumb bob. In this module, you have learnt that the role of chain in direct measurement is that of a reliable and hardy measuring device, useful for measuring long distances in sites with difficult terrain. You have also seen the different instruments used for chaining, such as chain, arrows, pegs, ranging rods and plumb bob.
Look at these two endpoints. With your chain, you can certainly measure the survey length between these points. Now, look at these two endpoints. Try measuring this survey line. The distance between these points is longer than the length of your chain. Even if you have two chains, it is not possible to measure this distance, as the chain will go one way or the other, and due to this, the length will not be accurate. By fixing intermediate points on a straight line between these two endpoints, you can make the survey line straight, and thus you can measure accurately the survey line of these 2 points. This process of fixing or establishing such intermediate points is known as ranging. But how will you do this ranging? Also, how can you do ranging when the 2 endpoints are not intervisible? What is the code of signals to be followed while ranging? Let's find answers to these and more in this module on ranging out survey lines. Welcome. After completing this module, you will be able to state the need of ranging in measuring the length of a survey line, describe the signals used in ranging, and perform. The typical length of a survey chain is 20 meters or 30 meters. But we do ranging if the length to be measured is more than the length of the chain. In this process of fixing the intermediate points, the surveyor and the assistant, that is, you, have to communicate. To ensure that this communication happens without any doubt, the surveyor and you have to use the code of signals for ranging. Observe these right-hand movements. When the surveyor does a rapid sweep with his right hand, move considerably to his right. When the surveyor does a slow sweep with his right, move slowly to his right. When the surveyor extends his right arm, continue to move rightwards. When the surveyor raises his right arm up and moves it to the right, plumb the rod to the right. Similarly, when the surveyor does a rapid sweep with his left hand, move considerably to his left. When the surveyor does a slow sweep with his left, move slowly to his left. When the surveyor extends his left arm, continue to move leftwards. When the surveyor raises his left arm up and moves it to the left, plumb the rod to the left. Now, observe these movements with both hands. Now that you have a fair idea of the code of signals for ranging, let's learn about the 2 methods of ranging, that is, direct ranging and indirect ranging. On a level ground, the distance between 2 points can be intervisible, that is, they can be directly observed by either the eye or through some optical instrument such as a theodolite. However, if the length to be measured is more than the length of the chain, then you have to fix intermediate ranging rods on a straight line from endpoints through a process known as direct ranging. Using the eye, let's observe the steps of direct ranging for these 2 endpoints. As a first step of direct ranging on a level ground, gather these instruments. A chain of 20 or 30 meters. 10 arrows. 4 ranging rods or more depending on the number of intermediate points. Fix the ranging rods at each end of the line to be measured, that is, A and B. The surveyor must stand about 1.5 meters behind the ranging rod at A by looking towards the line AB. The surveyor at A signals you to move crossways to the chain line until you are in line with A and B. When you come in the line of AB, the surveyor directs you to fix the rod in position, which is point C. Now, to establish another intermediate point, the surveyor stands about 2 meters behind the ranging rod at B by looking towards the line AB. Now, to establish another intermediate point, the surveyor stands about 2 meters behind the ranging rod at B by looking towards the line AB. You have to take another ranging rod and stand between A and B about 2/3 distance from B. As and when you are located in the line of AB, the surveyor directs you to fix the ranging rod in position, which is point D. Now, A, B, C and D are in one line. With A, B, C and D being in one line, the surveyor and you have to measure the distance along these points, that is, AC, CD and DB. When you sum the distance between AC, CD and DB, you will get the distance between A and B. Therefore, for measuring the distance between A and B through direct ranging, you must first gather the instruments. Fix the ranging rods at A and B. Then, decide an intermediate point C from A. Decide another intermediate point D from B. Often, a hill, pond, or a high ground can obstruct the view of two endpoints. When the endpoints are not intervisible by direct observation, intermediate ranging rods are fixed on the line in an indirect way known as indirect ranging or reciprocal ranging. Using the eye, let's observe the steps of indirect ranging for these two endpoints. As a first step of indirect ranging, gather these instruments: a chain of 20 or 30 meters, 10 arrows, 4 ranging rods. Fix the 2 ranging rods at the given stations A and B, which are not intervisible due to raising ground. Select 2 intermediate points M1 and N1 such that from each point both A and B are visible. The surveyor at M1 directs you at N1 to move to a new position N2 in line with M1B. You at N2 must now direct the surveyor at M1 to a new position M2 in line with N2A. The surveyor at M2 directs you at N2 to a new position N3 in line with M2B. You at N3 must direct the surveyor at M2 to a new position M3 in line with N3A. Repeat this process until the points M and N are located in such a way that M finds the person at N in line with AB and the person at N finds the person at M in line with AB. Now, measure the length of line AB, which is the distance of AM plus MN plus NB. Therefore, for measuring the distance between A and B that are not intervisible, you must follow these steps of indirect ranging. Gather the instruments. Fix the ranging rods at A and B. Select 2 intermediate points M1 and N1. Repeat the aligning process.
Let us take a look at the bridge again. As you can see, the pillars are spaced such that they bear the weight of the bridge only at those points where their support is essential. With the bridge in place between the two hills, it is very easy to identify where these points should be under the bridge, such as 1 point under the center of the bridge and 2 such points on either side of the central point at equal distances from it. But actually, what is constructed first? The pillars or the bridge? It is the pillars, correct? This means that the pillars must be constructed at certain points on the slopes, such that when they are raised to the height of the bridge, their tops become the bases which bear its weight at the essential support points. So, before beginning the construction of the pillars, a survey of the hills and their slopes must be completed. The survey map must contain the plotting work of the horizontal distances on the slopes, according to which the pillars for the bridge must be spaced. Now, there are two methods of finding out the horizontal distance on sloping grounds. The first is by chaining on sloping grounds, and the second is by using a clinometer. In this module, you have learned the importance of horizontal distance in plotting works. The two methods for getting the horizontal distance on sloping grounds, and how to determine the horizontal distance using the two methods. Prior knowledge of horizontal distances in plotting works is important for proper planning of construction tasks. The two methods of finding out the horizontal distances on sloping ground are by chaining and by using a clinometer. Stepping involves calculation of intermediate horizontal distances and adding them up. Errors in chaining also occur due to mistakes made by the surveyor. Let us take a look at what they are. Improper placement of arrows is an error that is made often. To avoid this mistake, the correct spot on the ground must be marked with an X. Sometimes, the chain length is not counted correctly. This mistake can be avoided by keeping a correct and careful count. A mistake can also happen when a tally at 15 meters is read as 5 meters. This mistake can be avoided by looking at the central tally. Finally, the surveyor might make the mistake of entering mixed-up numbers in the field book. This mistake can be avoided by calling out the numbers loudly and having them repeated while noting them.
1 meter,
1,
2 meters,
2 meters,
3 meter,
3,
So remember, improper placement of arrows, miscounting, misreading, and error. In this module, you have learnt the do's and don'ts that need to be followed. You should follow all the good practices of chaining, such as holding the zero end of the chain properly, calling out and repeating measurements, checking the teeth of the tally, opening and closing the chain properly. You should always avoid the incorrect ways of using the chain, such as taking measurements when the chain is not properly extended or when the chain is not horizontal during stepping. After completing this module, you will be able to state the use of survey stations in chain surveying and identify the conditions to be fulfilled by various survey lines. We see lines of different styles on survey maps or plans. They are named as the main survey lines, the base line, check lines, and tie lines. Let us know more about each of them. The base line is the longest line joining two main stations of the area under survey. Check lines are lines which are usually drawn from the baseline to a main station or a subsidiary. As the survey maps or plans are important for those using them, there are some conditions which must be fulfilled by survey lines. Let us find out what they are. First, the survey stations must be intervisible. Next, there must be a minimum number of survey lines shown on the map so that plotting the framework is made easier. Next, the framework or the survey drawing must contain one or two baselines. If one baseline is shown, it must extend along the length and across the central region of the area. If two baselines are shown, they must intersect in the form of the letter X. Then, the lines must extend as far as possible through level ground. Next, the main lines should form part of a well-conditioned triangle. Every triangle should contain check lines as required. As far as possible, the main survey lines should not pass through obstacles. So, keep in mind, these are the conditions to be fulfilled by survey lines. In this module, you have learnt about the use of survey stations, the types of survey lines, and the conditions to be fulfilled by survey lines. In surveying terminology, the prominent points of a survey are called main stations, and the minor points are known as subsidiary or tie stations. Main stations show the limits of the survey, while subsidiary stations serve as reference points. The different types of survey lines are main survey lines, the baseline, check lines, and tie lines. Main survey lines form the survey boundary lines of the area. The baseline is the longest line between two main stations. Check lines and tie lines help in checking the accuracy of the surveying work. Lastly, there are a number of conditions to be fulfilled by survey lines.
The cross staff is an instrument that helps in the calculation of right angles by sighting. Let us see how this is carried out. The cross staff is a thin pole with a pointed end so that it can easily be set into the ground. On its top, there is a square block of wood. There is a pair of grooves on the block, so the staff is called a block cross staff. As you can see, each groove lies in the center of one edge of the block, extending a little along its top and down its side. Also, the grooves of one pair lie squarely across the position of the other. To calculate right angles with the cross staff, set it exactly at the point on the survey line from which the right angle has to be calculated, with one of the grooves pointing to the ranging rod at the end of the survey line. When sighting the rods, note that you should be able to see the center of the rod when sighting it through the grooves. Also, you should be able to see the surface of the cross staff's block and the ranging rod, but nothing else between them. In the correct position, the grooves should be pointing straight to the center of the rod. Through the other groove, sight the other ranging rod, which must be held by another surveyor. Use ranging signals so that you can have it set exactly in the line of sight through the other groove. As the grooves of the block cross staff lie at right angles to each other, we can say that the ranging rods sighted through each of these grooves also lie at right angles to each other. So, remember, you can calculate right angles with the cross staff by sighting an object through one pair of grooves and sighting another object through the other pair of grooves. We have just had a look at the block cross staff. The other types of cross staffs are open cross staff, French cross staff, and adjustable cross staff. Let us take a look at each one of them. The open cross staff is a rod mounted with a pair of arms that intersect each other squarely. The ends of each arm are fitted with a piece of metal or wood. This piece is called the sighting vane. Each vane has a vertical slit containing a fine length of wire. An object can be sighted by peering through the vanes of an arm. The French cross staff is a tube made of brass. The tube has 8 equal sides. Each of the 8 sides is actually a sighting vane. The advantage of the French cross staff is that while right angles can be calculated by carrying out both the sightings through the vanes lying directly opposite each other, angles of 45 degrees can also be calculated when the second sighting is carried out through the vane adjacent to that of the first. The adjustable cross staff is a rod mounted with 2 cylinders which are placed one above the other. Both the cylinders have slits for viewing. The upper cylinder has a vernier, while the lower one has a graduated scale showing degrees and subdivisions to calculate angles. So, remember, the 3 types of cross staffs are open cross staff, French cross staff, and the optical square is a device that helps us calculate or mark or sight angles with the help of the reflected image of an object. The surveyor is able to calculate right angles with the optical square by sighting a ranging rod through a sighting glass and identifying the line forming the right angle based on a reflection above the glass. So, remember, the optical square is an optical device that uses reflection to calculate the right angle. In this module, you have learnt how to identify the instruments required for right angles and how to use those instruments. One of those instruments is the cross staff, which consists of a pole mounted with an arrangement of slits called sighting vanes. To calculate right angles with the cross staff, you should sight the ranging rod on the survey line with one pair of vanes and then sight another object with another pair of vanes. The different types of cross staff are open cross staff, French cross staff, and adjustable cross staff. The other instrument is the optical square, which uses reflection to calculate the right angle.
अरे गीता, तुम मेरे घर आई ये तो बहुत अच्छी बात है। वास्तव में मुझे इंटरनेट के बारे में कई महत्वपूर्ण बातों को समझने में तुम्हारी मदद की जरूरत है।
जरूर चाचा, मैं यहाँ आपकी मदद और मार्गदर्शन के लिए आई हूँ।
देखो गीता, जब मुझे ट्रेन से कहीं जाना होता है तो मुझे बहुत मुश्किल समय का सामना करना पड़ता है।